Theo is right. Coding isn't the bottleneck anymore. Millions of people got access to code, but almost nobody can architect software that survives real users. I'm studying cloud computing and software development at uni, and I'm going to share with you how can you stand out from other vibe coders and actually make sure your software works. Vibe coding is fun until you ship something real, because the moment real users show up, the rules change. The gurus will tell you that you don't need technical knowledge anymore. If you bought that, you are not alone. I did too at first. I'm a cloud computing and software development student at uni, and I've learned this the hard way. AI can generate code, but it cannot generate ownership. And the people who stand out in this new era aren't the fastest prompt writers. They are the ones who can explain what they shipped, defend the architecture, and keep it alive in production. Today, I'm going to tell you the 5 things that I believe will make you look like an engineer in the AI world, plus what a successful vibe coder actually is when you strip away the hype. Yes, code is cheap now. That part is sorted. The rare skill is knowing what the code should look like when it's done. So let's talk about what actually changed. Everyone is saying that coding isn't a bottleneck anymore. Theo said it, Dario from Anthropic said it, and they are right, but most people are hearing the wrong thing. What they hear is that cool, I don't need to learn the fundamentals anymore. But what it actually means is that the bottleneck moved upstream, it moved to understanding, to architecture, and to verification. Here's why it matters. AI can generate 1,000 lines of code in 30 seconds. That's amazing. But it has no idea if that code is the right code. It doesn't know if your database schema is going to blow up at scale. It doesn't know if your auth flow has a race condition. It doesn't know if your API keys are about to leak to GitHub. And here's what I've seen over and over. Apps that look perfect in the demo, the UI works, the buttons click, everything vibes. Then you deploy to production and chaos. You see authentication edge cases you didn't test, rate limits you didn't anticipate, weird user inputs breaking validation, or even payments failing silently, or even worse, secrets showing up in logs. This is the new reality. Everyone has access to code, but almost nobody has access to judgment. So the thing that makes you stand out now isn't prompting better. It's actually 3 things: taste, constraints, and review. Think of AI as your intern. It's brilliant, it's super fast, but it has zero common sense. And your job isn't to type faster than the intern. Your job is to be the tech lead who says, no, that's not how we handle authentication here, refactor it. Or why did you use this library when we already have one that does the same thing? This has no error handling. What happens when the API is down? That's ownership. And when you ship something, you should be able to answer 3 questions without looking at the code. What happens when this fails? Where does the data go? And what is the attack surface? If you cannot answer those, you don't own it, you just deployed it. And trust me, the market is already noticing. There is an entire economy forming around cleaning up vibe slop. Teams are spending weeks fixing AI-generated messes because the person who shipped it couldn't explain what it did. If you become the person who prevents that mess, you win. And if you only remember one line from this video, make it this. You don't stand out by prompting better, you stand out by owning what the prompt produced. Okay, so let's turn ownership into something you can actually do, not something you just believe. If your plan is, I'll figure out in Cursor, you are already behind. Most vibe coders start projects the same way. Build me a SaaS or make me a social media app, and then they just wing it. They let the AI decide the stack, the data model, the authentication, basically everything. And that's how you get a Frankenstein app. 7 different libraries doing the same thing, no clear boundaries between frontend and backend, a weird data model that makes sense in isolation but breaks the second you add a new feature. And here's what the standout builders do instead. They start with a 1-page spec, not a 50-page document, not a Jira board, just a single page that answers the important questions before a single line of code gets written. And here's what goes in it. Problem. What are we solving? 1 sentence. User, who is this for? Be super specific. Success metric. How do we know if it worked? Downloads, revenue, time saved. Non-goals. What are we explicitly not doing? This is also huge because it prevents the scope creep. System boundaries. What are the pieces? Front-end, back-end database, third-party APIs, draw boxes and arrows if you need to. Data model first. What are the tables or collections? What are the relationships? User has many posts or a post belongs to a user. Basically simple stuff. But doing this before you code saves you from rebuilding your database 3 times. Failure modes. What if the payment fails? What if the webhook sends duplicates? What if the user abandons the flow halfway through? Once you have this, your prompt changes. Instead of build me a SaaS, you say implement this spec, use better auth for authentication, PostgreSQL for the database, here's the schema, here are the routes, here are the edge cases. You see the difference, right? You went from passively receiving whatever AI gives you to actively directing what gets built. And I'll be honest, I learned this the hard way. I tried the just build it approach on a project last semester. Spent 3 days building features and realized my auth system didn't match my actual user flows. I had to tear it down and start over. If I had written a one-page spec first, it would have caught it in like 10 minutes. This single step cuts rework by like 70% because you stop rebuilding the same feature 3 different times. Next one is the difference between works on my machine and I can put this on my portfolio without fear. Once you have a spec, you need something most vibe coders refuse to do, which is verification. Successful vibe coders aren't magical. They are paranoid. And here's the biggest vibe coder failure mode I see. Trusting the output because it looks right. The code runs, there are no red squiggles, the feature works when you click it, ship it, and that confidence, that's the gap, because it works when I click it is not the same as it works when 1000 users hit it at the same time with edge cases I never thought of. This is where the confidence to competence mismatch shows up, especially with authentication, payments, permissions, the stuff that breaks silently and costs you users. So here's the shift. Your new job title is Verifier-in-Chief. You are no longer the code writer, you are the code reviewer, and your job is to be paranoid, like super paranoid. Here's the minimum test set I use for every feature I ship. 1 is the happy path, the basic it works case. 2 is one nasty edge case. What if the input is empty? What if it's way too long? What if the user submits twice? 3, one security or permission case. Can a logged out user hit this? Can a user A access user B's data? That's it, 3 tests per feature, not 100, just 3 good ones. And then automate the boring stuff, linting, type checking, formatting, let the machine do the machine work. But here is the real unlock. Use AI properly in this step. Don't just ask it to write a feature, ask it to generate tests that try to break this logic. What are the 3 ways this could fail in production? Is there a race condition here? Turn it into your code reviewer. Make it attack your own code. And yeah, writing tests feels slow at first, but here's what nobody tells you. Even a small test suite makes you faster over time because you stop re-breaking old features every time you add a new one. But verification is still not enough because you can test a feature and still leak a secret. And that takes us to the one layer that quietly ends projects. You can be a decent coder and still accidentally build a data breach. Let's talk about the nightmare scenario. You build an app, it works, you deploy it, users are signing up, everything is great. Then someone posts a screenshot on X and it's your API key exposed in your client-side code or in your logs or in a public GitHub repo. Game over. And here's the thing, AI loves to hardcode stuff. It will put your database URL right in the code. It will create an admin route with no auth check. It will set permissions to public by default because that's easier. This is where being a cloud computing student gives me an edge, because in my program, they drill this into you. Security is not a feature, it's a default. So here's the boring checklist that separates portfolio projects from prod-ready software. Secrets. Everything sensitive goes into environment variables. API keys, database URLs, tokens, never in the code. Never committed to Git. Use secret managers if you're serious. Authentication. Don't invent your own, use a known library. Nextauth, Supabase auth, Clerk, something that's been battle tested by people smarter than you. Permissions, deny by default. If you are not sure whether users should have access, they don't. Make them prove it. Input validation, treat every request as hostile until proven otherwise. Sanitize inputs, validate types, and don't trust the client. And here's a prompt that I use constantly. Threat model this endpoint. What's the abuse case? How would someone break this? Let the AI red team your own code. I'll give you a real example. Last time I was building a file upload feature for a project. AI generated the code, it worked, but when I asked it to thread model the endpoint, it flagged the bucket was public by default. Anyone with the URL could access anyone else's files. One question caused a disaster. This is the difference between a demo app and something you can actually scale. Security hygiene. Next one is where most people permanently stay junior, because they use AI to avoid debugging. If you want to look senior fast, you don't avoid bugs, you harvest them. Every bug you skip is a senior skill you never earn. Here's the workflow I see constantly. Error happens. Copy the stack trace, put it into ChatGPT, apply the fix and move on. And look, that works. The error goes away, feature ships, you are productive. But here's what you lost. The understanding. Because if you never actually learn why it broke, you are gonna hit that same class of bug next week, and the week after, and 6 months from now, you will still be Googling the same error message. This is what I mean by the skill erasure problem. If you let AI be your mechanic instead your tutor, you never build intuition. So here's the shift. Use AI as a teacher, not a fix-it tool. Before you even ask AI for help, write down your hypothesis. One sentence. I think it is failing because the async function is returning undefined before the fetch completes. It doesn't matter if you are right. The act of forming a hypothesis makes you think like a debugger. And then you can ask AI like, explain this error like I'm onboarding to this code base, or list 3 root causes ranked by probability, or even what would a senior engineer check first. But I hope you see the difference now. You are not asking it to fix the bug, you are asking it to teach you how to fix the bugs. And here's the other piece, observability, logs, metrics, or request tracing. Most vibe coders ship apps with zero logging, so when something breaks, they have no idea what happened. They just know that it doesn't work. So, you need to add structured logs, add request IDs so you can trace a single user journey, add basic metrics, latency, error rate, or success rate. And yeah, most definitely, this sounds like an overkill for a side project, but this is exactly how you build senior instincts as a junior. So I literally keep a bug diary. Sounds nerdy, I know, but it is just a Notion page where I log the top 10 bugs I hit and what they taught me. For example, auth token expired because I forgot to refresh it, or database query failed because I didn't handle null values, or course errors because I forgot to whitelist the domain. After a month of doing this, you stop being surprised by the same failures. You start recognizing patterns, and the pattern recognition is what makes someone look senior. Last one is the reason cloud students and DevOps-minded people look like wizards in vibe coding circles. Because software isn't just code, it's where the code lives. If you cannot deploy it, you didn't build it, you assembled it. Most vibe coders stop at it runs on my laptop. And look, that's a start. But running locally is not shipping. Shipping is when real users with real data can break your app in real ways. And deploy day is where the horror show begins. Like for example, environment variables are missing, your local node version is different from production, course issues that didn't exist locally suddenly appear, database migrations break because you tested them exactly once, SSL certificates expire, or webhooks fail silently. And this is where ownership shows up. Not in the code, it's in operations. So here's what separates a cool demo from real software. Environment parity. Your development environment should look like staging. Staging should look like production. Same database, same environment variables, same versions, no surprises. CI/CD at minimum. GitHub actions that run your tests on every push, catch the bugs before they hit production. Infrastructure basics, domains, HTTPS, storage permissions, or backups. These sound boring, but they are the difference between I built a thing and I own a thing. You also need to have a rollback plan. What happens if this deploy breaks everything? Can you undo it in 30 seconds? Or are you scrambling to fix it live while users are hitting errors? Here's a prompt that I use before every deploy. Create a deployment checklist for this stack and highlight the risky steps. Just let the AI be your pre-flight checklist. Let me give you a real example. A few weeks ago, I deployed a project to Vercel. It looked perfectly locally. I hit deploy and I got instant 500 errors. Spent 20 minutes panicking before I realized that I forgot to add the database URL to the environment variables in Vercel. One checklist item would have caught that. So from now on, I have a deploy checklist pinned in my Notion. Environment variables, migrations run, course whitelist updates, logs configured, and rollback tested. Boring? Yes. Professional? Also yes. This is the layer that separates I made a cool app from I'm responsible for software that people depend on. Alright, so those are the 5. Here's the punchline that ties them together. Successful vibe coders aren't non-technical, they are just technical in a different way. So let's kill the myth. Successful vibe coders aren't people who skip the fundamentals. They are not people who got lucky with good prompts. They are people who understand something most others miss. The job changed, but the rigor didn't. And here's what actually makes a successful vibe coder. 1. They think like an orchestrator and not an operator. The operator's mindset is like AI. Take the wheel, build me the thing, then they just hope it works. The orchestrator mindset is, here are the constraints, here are the boundaries, here are the acceptance tests, go build inside that box. You see the difference, right? One is passive and one is architectural. 2. They can explain what they ship. If you cannot explain the authentication flow to a teammate without looking at the code, it's not yours. If you cannot draw the data model on a whiteboard, you didn't design it, you accepted it. Successful vibe coders can defend their decisions. I chose PostgreSQL or MongoDB because our data is relational and we need transactions, not the AI picked it. 3. They verify relentlessly. Tests, review checklist, threat model, edge cases. They are paranoid because they know the AI doesn't care if it ships broken logic. 4. They own outcomes. Not just did the feature ship, but does it work under load? Is it secure? Can I debug it when it breaks? Will it still work in 6 months? They treat the software like it has their name on it, because it does. And 5. They communicate clearly. Specs, diagrams, small well-defined tasks, clean handoffs, because they know that the vague inputs create vague outputs. And if you are thinking that this sounds like a lot, good. That's why it's a moat, because the bar is low right now, which is amazing news if you are willing to do the basics. If you are tired of shipping broken apps, the fix isn't some secret prompt, it's ownership. Coding got democratized, architecture and responsibility didn't. So here's the scoreboard. 1. Write a spec. 2. Verify with tests and checks. 3. Build security hygiene into the defaults. 4. Debug to build intuition. 5. Deploy like you're the one getting paged at 2 AM. Do that consistently and you will stand out fast, because most vibe coders are still optimizing for the demo, not the system. The gurus will tell you that you don't need to be technical anymore. They are wrong. You need it more than ever. You just apply it differently. You're not the typist, you are the tech lead. Drop a comment below with the most painful way an AI build project blew up in your face automatically, whether it was a deployment disaster, an auth leak, or a broken payment flow. I'll pick a few of the best ones and do a reverse engineering breakdown of exactly why it happened and how to fix it. Also, if you want the exact architecture checklists and templates I used to build these systems, hit the link in the description to join the free newsletter. And if you want more videos like this, cloud fundamentals and security explained for people building with AI, make sure to hit subscribe. You're leaving the slop behind and building real systems, because around here, it's good vibes only. Ship fast, but ship like it's real. I'll see you in the next one.